Right, so let's have a look at partial fraction expansion. What I'm going to do is take a fairly simple example and I'm going to expand it or break it up into two fractions that you can add or subtract to get that original fraction. So in other words, I'm going to take this one here. I'm going to take 1 over x squared minus 1. Now what I'm going to do is I'm going to divide this up into two different fractions. When you add them or subtract them, you end up with this here. So in other words, if you take a simple example, not an algebraic one, if you take 2/3, that's just the same as 1/3 plus 1/3. So I've taken this 2/3 and divided it up into two different fractions added. So this one is a fairly obvious one. This one not so obvious, but let's see how you can do it. Well, first thing you got to realize here is that this is if you like, a proper algebraic fraction. In other words, the degree of the expression in the numerator is less than the degree of the expression in the denominator. In other words, the power of x in the numerator is less than the power of x in the denominator. The power of x in the numerator is actually 0, and the power of x in the denominator is actually 2, so it's larger. So it's like 2/3, if you like. 2 is smaller than 3, so this is a proper fraction. So first thing you got to do here anyway is factorize the denominator. So it's going to be x minus 1 times x plus 1. So all I've done is factorize. This is the difference of two squares here, so that's just x minus 1 times x plus 1. Now next thing, what we want to do here is divide this up into fractions that you can add or subtract, that will give you this when you add or subtract them. So in other words, what I'm going to do is take a numerator that I don't know, denominator that I do know, another numerator that I don't know, and this denominator here. So I can see, this is why I factorized it. I know that if I were to add these two fractions here, my common denominator would be x minus 1 times x plus 1. The thing I don't know is the a, and I don't know the b. So let's see if we can work out what a and b would be in order to give me a 1 up here. So first thing we're going to do is just add these two fractions. So my common denominator is x minus 1 times x plus 1. Now divide the a minus 1 into this here, you get x plus 1. X plus 1 times a is a times x plus 1. Plus divide x plus 1 into this here, you get x minus 1, so you end up with b times x minus 1. Okay, so next thing I'm going to do then is, now there are a couple of ways of proceeding from here, but I'm going to do it this particular way. I'm just going to multiply out the top line here. So I end up with ax plus a plus bx minus b, and again that's all over x minus 1 times x plus 1. Okay, so this is my fraction. I don't know what a and b are, however I know that they should equal I know that this should equal 1 over x minus 1 times x plus 1. So I want to work out what a and b I could put in here to give me a 1 on the top here. So let's see. What I'm going to do next is just write down ax plus a plus bx minus b. I want that to be equal to 1. So in other words, my numerator here I want to be equal to 1 here, the numerator here. The denominator is already the same. So what a and b would give me 1 here. Once I find out what a and b are, I can put them in here, and that will give me my two fractions. So let's just solve this here. So if I take the ax and the bx here, I can write them together. So I can write a plus b times x. All I've done is taken these two here, put them together, and factorized out the x. Now what have I got left? I got plus a minus b, and I want that to be equal to 1. Now if I look at the left hand side, I've got some number times x plus some number. This is just a number here with no x, if you like. On the right hand side here I've got a 1. I'm going to change that 1 to look like this: 0x plus 1. 0 times x is just 0, so I haven't changed anything here. I still have just the 1 on the right hand side. What I can do now is just equate the coefficients of x, if you like, here. So a plus b is just going to be equal to 0, and this is the numerical part here independent of x, and this is independent of x here. So in other words, a minus b is just going to be equal to 1. Okay, so I've got two equations here. I've got two unknowns, a and b, so I can solve this. I don't have to do anything with the two equations because I can already cancel this, these two b's here. If I add the two a's here, I get 2a. These two cancel to give me 0, and I just end up with 1 here, and that just finally gives me a is equal to half. So now I know what a is. Let's just try and work out what b is. Well, if I take equation 1 again, I've got a plus b equal to 0. I know that a is equal to a half, so I can put half here and put b here, 0 here. That will give me b is equal to minus half. So now I know what a and b are. Okay, so let's put them into our original equation. Remember, our original equation was 1 over x minus 1 times x plus 1 is equal to, we had an a over x minus 1, and then we had a b over the x plus 1. We didn't know what a and b were, but we do now. So now we know that this is, a is a half, and that's over x minus 1. b is minus a half, so I'm going to put minus half here, and we've got the x plus 1 here. Okay, so let's just tidy this up a little bit. This will give me 1 over 2 times x minus 1 plus, no, it's not plus, it's actually minus here. This minus here and this plus will give me minus 1 over 2 times x plus 1. Okay, so this is our answer really. So these two added together should give me my original fraction. My original fraction, remember, was 1 over x squared minus 1, which is just 1 over x minus 1 times x plus 1. So what I'm saying now is that all of this here, these two added, should give me this here, or this here eventually. So let's just test that to see does it work. So we'll just do a quick test here. So I'm going to add these two fractions here. So my common denominator is 2 times x minus 1 times x plus 1. Let's divide this into all of this, and you get x plus 1. Multiply that by 1 on the top here, and you get x plus 1. We have a minus here. Divide 2 times x plus 1 into our denominator here, you get x minus 1. Multiply that by 1, we just get x minus 1 up here. If we take away the brackets here, we end up with x plus 1 minus x plus 1. This minus minus will give me a plus here, and on the bottom here we end up with 2 times x minus 1 times x plus 1. Finally then we end up with this x and this x will just cancel, give me 0. Here we end up with 2 over 2 times x minus 1 times x plus 1. Let's just move this up a little bit. What I can do now is divide this 2 into this 2 here. I'll just move over here just to leave this in screens here. So we end up with 1 over x minus 1 times x plus 1, and finally our denominator then is just, this is the difference of two squares here, so it's x squared minus 1. So this here is what we end up with if we add these two fractions here. And that's it really. I mean, we've taken this was our original fraction, and we've split it up into two fractions that we can add or subtract in this case to give us this fraction here. And this technique will be useful in various topics in mathematics, but I'm just showing the technique here. So this is a simple example. I'll do more detailed examples in subsequent videos.